Okay, so let's talk shortly about Elgamal digital signature. It lets the user or someone that sees your message know that it's authentic. So the signature goes by this. We'll have a message and we sign this, but we need to start with the setup. The setup said that we are taking P, which is a prime number, generator, if you want to call it a primitive, and a multiplicative group of P. So we set up those P, G, and we have multiplicative group. Now we choose a secret, which is X. It should be between 1 and P minus 2. And we create public key, which is Y equals the generator to the power of X mod our P. After we did this setup, we get P, G, our secret key, which is X, and the public key, which is Y. Of course, for an attacker, it will be very hard to get the X, even though it will see the Y and will know the G. The reason is because the discrete logarithm problem. The discrete logarithm problem in a finite group say that it's very hard to get this exponent, to solve for this exponent, even though you know the y and g. So solving for x is very hard. So even though the attacker can get y and g, it will be very hard for him to solve for x in this finite field. Now let's sign our message. Let's call the message m. Alice will again choose a secret integer k between 1 and p minus 2. It also should be with greater common divisor with p minus 1 to be 1. The reason is that we will need to use the inverse of k. So this will say that we will have an inverse. Now Alice will compute r and s. R is g, which is the generator, powers the secret integer k, mod p, and s will be hash of the message minus x, which is a private key, times r, which we just calculated, to the power of k minus 1, the inverse of k, mod p minus 1. R and S will be the signature. Now, someone will get this and will need to know, he will get the message, he will get R and S, and he will ask himself, does this message is authentic? This M that I got. Now to verify the signature, I get a message M and I get those two, and I want to know if the message is authentic. What I do is calculate G to the power of hash, the same hash of M mod P. If it equals Y, I can get Y to the power of R, I get R, times R, the same R, to the power of S mod P. If there is an equation, if those two values equal, it says that the message is authentic. If there is inequality here, I calculate this and I calculate this and I get two numbers that are not the same, it means that something happened. Someone attacked, something happened, and the message is not authentic. So this is how Elgamal digital signature can tell me if the message that I got is authentic, yes or no. And that's it. That's the idea. Create the setup, sign the message, send it, someone get the message, and check if the message is authentic, yes or no. If there is equation, is those two values are equal, yes or no. And that's it. This is in short about Elgamal digital signature.